Okay, so today we're going to be talking about scientific notation. I'm CStrong.
I am Jennifer Utz.
And we're both faculty in the School of Life Sciences. So, why are we making you understand and be able to do scientific notation? Jen, why? Why are we doing this?
I promise there is a reason. We never make our students do something for no reason. So the reason we have scientific notation is because in science, we deal with values that can be very, very large.
So like 1 million?
Absolutely. We also deal with values that can be very, very small.
So like 0.000000002.
Yes, exactly. So it can become really challenging to be writing tons of zeros before or after a decimal place to represent these really large or really small values. So scientific notation is a system that we use to represent the values in a more concise manner. So when we represent a value in scientific notation, we have 3 components listed here. So one component is the coefficient. So we'll mark each of these components in our representation in scientific notation. So our coefficient typically is going to be a number, perhaps with 1 decimal place, and then our base, in this case, is 10, and most of the values we use will be on a base 10, and then our exponent, in this case, is 3. And the way we would say that number is 1.5 times 10 to the third, right? Or 1.5 times 10 raised to 3, if we want to be a little more elaborate. Okay, so these are the components. We need to be able to represent values in scientific notation, and we also need to be able to perform a couple types of calculations. So what type of calculation might I need to do, Christy?
What if you had to add 2 large numbers that were in scientific notation?
Okay, that's something that we might have to do.
Yeah, so let's say 3.2 times 10 to the 6th.
Okay.
And I want to take that, and then I want to add 4.1 times 10 to the 7th. So 2 large numbers, both of them written in scientific notation. How would I, as a scientist, know how to process this?
Okay, so there are some rules, basically, that we can think about when we're working with these numbers. So there's different rules for adding and subtracting versus multiplying and dividing. So to add or subtract, one of the first things we need to do is make sure that our exponents are the same.
Okay, so
you were very clever. You set up something where the exponents are not the same.
Okay, so where I'm putting the asterisk, I can see that the 6 and the 7, it's not the same number, so the exponents are not the same.
Correct. So if we're going to perform an addition or subtraction, the very first thing we have to do is convert one or the other of these numbers such that the exponents are the same.
Okay, so say I like 10 to the 7th.
Okay.
How am I going to convert 3.2 times 10 to the 6th to 10 to the 7th? What would I have to do?
So when we're working with base 10, our decimal place will move by 1 position for each change in the value of our exponent. Absolutely.
Okay.
So we could
to the left.
Yep. We will move our decimal 1 to the left in order to increase our exponent by 1. So 0.32 times 10 to the 7th is representing the same value. Okay, so our exponents are now the same, so we can move forward with our calculation.
Okay.
So when we're performing an addition, all we're going to do is add together our 2 coefficients.
Okay, so I got to take this 0.32, and then I need to then add that 4.1.
Correct.
Is that correct?
That is correct.
Okay, and so this is pretty simple math. I feel confident I can do it. So I just go 4.1, and I'm going to put a 0 there as a placeholder just because I have 0.32 and I want to keep things straight. I lose numbers if I don't have placeholders.
Absolutely.
So we've got 2, 4, 4. So 4.42.
Fantastic.
Okay.
So that's our coefficient, and then when we're adding and subtracting, our base and exponent would stay the same.
Okay.
So our final answer...
That's pretty straightforward.
It is pretty straightforward. So our final answer would be 4.42 times 10 to the 7th.
Fantastic.
And then if we were subtracting, we'd follow a similar path. We have to make sure exponents are the same. We already took care of that. And then when we're adding, we add our coefficients, and when we're subtracting, we would subtract our
So I would just go
coefficient.
4.1 minus 0.32.
Yeah, if that was our setup, absolutely.
Okay.
And then our base and exponents stay the same.
Fantastic.
So the important thing to pay attention to is just that first step of double checking that the exponents are the same, and then converting one or the other, whichever you choose, if they're not, to make sure they are the same.
Okay, so we've got a set of rules here, but we know life is not this simple, right?
Yeah,
So-
we don't only need to add and subtract, you're right.
What if we wanted to multiply? So I wanted to take two large numbers represented in scientific notation, and then I wanted to multiply them together. I'm assuming if I have rules for adding and subtracting, I have to probably have rules for multiplying.
Yes, we do. So can you give me a setup and we'll work through
so
practice?
let's go 6.5 times 10 to the 9th, and I'm going to multiply that number by 1.3 times 10 to the 7th.
Times 1.3 times 10 to the 7th. Okay, so when we're multiplying or dividing, we're somewhat similar in that we're going to kind of have a processing piece for our coefficients and then a processing piece for our base and exponent values. But what happens with those numbers is going to be a little bit different. So when we're multiplying, we are going to multiply our coefficients. So 6.5 times 1.3, which would equal
8.45.
We're
We're going to let them use a calculator, right?
Yeah,
Because
yeah,
we don't-
absolutely. You know, this was straightforward enough we could work that by hand, but multiplying and dividing, we can get some help from the calculator. So we're going to multiply our coefficients.
Okay.
And then when we're multiplying, our rule is that we will add together our exponents. So 9 plus 7 is 16.
Oh, that's
So
pretty
our final
straightforward.
answer here, yep, process the coefficients, process the exponents. So multiply the coefficients and then add the exponents. So our final answer here would be 8.45 times 10 to the 16th.
Okay, dividing. You know, if we multiply, we got to be able to divide.
Correct.
So is it going to be the same rules, or are we going to tweak it?
It's going to be similar, but not exactly the same. So we're going to start kind of the same way. We're going to start processing our coefficients, but now we will divide them. So 6.5 divided by 1.3. You want to plug that into the calculator for me?
Yes. Okay, 6.5 times, oops, no, not times.
Yeah, divide.
Got to change it. 6.5 divided by 1.3 is 5.
Oh.
Even Steven.
How convenient. So we divide our coefficients, and then when we're dividing numbers in scientific notation, we are going to perform a subtraction for our exponents. So when we multiplied, we added together the exponents. When we divide, we're going to subtract them. So 9 minus 7 equals 2. So our final answer for the division would be 5.0 times 10 to the second power.
Okay, so we know that students are going to have to do these calculations in lab.
Yes.
And if you're nerdy like us, because we're nerdy,
Yes, we are.
I'm all about the note card. Why not write the rules down, tape it into the inside of your lab notebook so you're not stressing trying to flip through all of those pages finding this stuff, right?
Absolutely. I think that's a great point. Time management, especially in lab, is really important. And this information may be all over the place. So a perfect thing to do as a student is to bring it all together, right? And kind of set up your rules for adding and subtracting, set up your rules for multiplying and dividing. And then when you look at a problem, identify the nature of the calculation, go to that set of rules, and then perform your processing for the coefficients and your processing for the exponents. And that's it.
Okay, so easy rules. Like, okay, if I want to add and subtract, add my lovely little coefficients.
Right? Or
right?
subtract them.
But before I can do that, make sure that I'm in the same exponent. If I'm not in the
Yes.
same exponent, make sure I get in the same exponent. Once you're in there, add or
Done.
subtract.
Perfect.
Easy peasy. Multiplying, right? You can multiply your coefficients, fantastic. And then we have to add our exponents.
Correct.
And then dividing, we divide our coefficients, and then we subtract our exponents.
That's it.
So pretty straightforward set of rules. Now we know that when you're doing the calculations, it's really important that you write down the correct answer. And so sometimes what
Yes.
happens in lab is a student will write something like this, like 50.0 times 10 to the 6th. why would an instructor be like, you're not quite there yet?
Yeah, so sometimes when we're performing these calculations, we might end up with a larger or potentially smaller final value. So it's important to remember the overall goal of scientific notation was to have the most concise, focused representation. So if we had 50.0 times 10 to the 6th, we could represent that another way, which would be 5.0 times 10 to the 7th, moving the decimal, adjusting the exponent so that we get kind of the most concise version of that final answer. So that's a good point. We have to remember the rules for kind of processing our calculations, and then we also need to double check our final answer and make sure that final answer is represented in the best, most accurate version of scientific notation.
Okay, so if they move the decimal point to the left, the exponent has to go up every place that it moves. If they were to move it to the right, the decimal would go, or the exponent would go down. So that's a good rule to make sure that they understand. Going to the left, exponent goes up. Going to the right, exponent goes down.
Yeah, that might be good to put on the note card too.
Yes. Okay, so you're going to practice some practice problems after viewing this video so that you get more and more comfortable doing this, because you're going to have to be able to do this in lab. So you're going to have experiments that are going to require this, and plus this may be on, your quiz material, so it's always good to become proficient in a skill set that will require you to actually be able to do in real life.
Absolutely.